Muscles in the body contract often. Contrary to what most people think, muscle contraction does not necessarily mean that the muscles change length. Sliding filament theory is the explanation for how muscles contract to produce force.
Muscles are made of sarcomeres, which are structural units in the muscle. Within the sarcomere, actin and myosin are present. Actin is the purple thin strands, and myosin is represented by the thick red strands.
For muscle contraction to begin, a nerve impulse is required. This impulse travels from the purple axon terminal to the pink neurotransmitters, down the sarcolemma to the T-tubule represented in red. The place where the axon terminal and the muscle fiber connect is called the neuromuscular junction. Surrounding the T-tubule is the green sarcoplasmic reticulum, which is the cell's storage and transport system. This holds the calcium ions represented by purple stars.
This impulse initiates the release of calcium ions. These star-shaped calcium ions bind with the green troponin on the actin.
This binding displaces the location of tropomyosin and exposes the red dots showing the myosin binding sites. The red myosin head is currently bound to an ADP and phosphate molecule from the past contraction.
The phosphate molecule is released so that the myosin heads bind to the actin myofilaments. This formation of a cross bridge allows a power stroke to occur and the movement of the head back and forth, stimulating contraction.
The myofilaments complete a successful contraction by reducing the distance between each Z-line of each sarcomere. As the units move, they release,
then breaking it down back into ADP and phosphorus to be used in a future muscle contraction. Rigor mortis is the stiffening of joints and muscles a few hours after death.
This process does not immediately occur because the body is still performing anaerobic respiration for a few hours, so some ATP is still produced. When no more ATP is present, a key step in muscle contraction cannot occur.
This prevents the detachment of the myosin head to the myosin binding sites on the actin. At this point, the cross bridge cannot be broken.
This leaves the body in a constant state of contraction and prevents the gliding movement otherwise happening. This process lasts approximately 72 hours and is a direct result of ATP lack in the body.